Sorry. Anybody ever wrote any MPI code or parallel code? So MPI is like I said, it's an application programming interface, an API, and they have APIs for MPI, which is it's a group of people, a standards organization, a group of people got together and decided that these are the particular function calls. This is the function is going to read like this and take these arguments, and it's going to return this. Okay. But how you actually implement that is up to different people. And for a while, there were many different people working on that. Now it's down to about 2, really. Open MPI, which is an open source MPI that you can download, and MPICH. They both implement the same standard. In other words, if you write the code where you have this function call and it takes these arguments and you expect this return, you can compile your code with either one, with the Open MPI library or the MPICH libraries. MPICH, or specifically MPICH, is really implemented in a way that really takes advantage of InfiniBand machines, right? So on TAC, on the supercomputer, they have an MPICH implementation, and you can actually realize some gain by using that, linking to that set of libraries from this. So I just have a few slides, and again, if you take my class, I'm going to go fast through this. We'll go really slow and work lots of problems and other things. But this is the interfaces for the API are in C and C++ and Fortran. I mean, those are your compiled scientific computing languages. Fortran's sort of a legacy one, but if you're going to set out today, I mean, in other words, there's still a lot of code around that's written in Fortran. But if you're going to set out today to write something from scratch, production quality code, you're really glutton for punishment if you use Fortran. You should absolutely use C++. And C++ is a superset of C, right? So any C++ compiler can call C, and a lot of our sort of gut routines and codes are really just written in pure C, right? Because nothing's faster than that, right? But one of the reasons I really advocate for Python, because you've heard me say many times in the class, Python can do everything MATLAB can do, right? It absolutely can. And Masood, you've been learning it, right? You didn't know Python until this year. Would you disagree? Have you encountered anything that you could do in MATLAB that you can't do in Python? You can absolutely do everything, but you can do more. And specifically, what you can do is MPI. So there's a set of Python wrappers in a package called mpi4py, which essentially just wrap the C++ functions. So you still have to have a compiled C++ Open MPI or MPI library that you're linking against, but these guys wrap that, and then you can use it straight from Python. But the real sort of, I'll show, the real operations, the send, the receive, the gather, the scatter, the collective sums, all of that's really just done in C. These are really thin wrappers around the compiled code. That's something that's not available in MATLAB, okay? And the cool thing is that the API, the way that this is written, is in one-to-one correspondence with C++. So in other words, what I mean by that is that the structure of it looks exactly like it does in C++. It's just a little bit more syntax in C++, of course, because you have, Python, like MATLAB, is dynamically typed. You don't have to declare variables and all that, where you would in C++, right? So it's just a little more syntax here, but structurally everything is the same here, and that's one reason I advocate for Python, because all you guys that use MATLAB and you get to that point where you can't solve your problem you want to solve, because you're going to have to rewrite your entire code to get a parallel efficient code, right? If you started in Python, you can immediately move to mpi4py, and if you're using the NumPy data structures and everything for Python, you're almost getting near C speeds when you do that. I mean, I have a little 2D paradynamics code. It's on my GitHub site, PDPy. It's very limited in what it can do. It's just like a 2D plate you pull on it and cracks grow. But if you compare that to Paradigm, which is our production quality C++, for that type of problem, 2D problem, pull on a plate, the PDPy code is just as fast. And it's all written in Python, wrapped with, well, it's actually a step further than MPI4py. It uses Trillino stuff, which we might get to. So, these are some of the details, but basically, you have to pass these messages, which messages, you could think of as, it could literally be a message, a string, right? But more often in scientific computing, it's data, right? You're passing data from one processor to the other. And there's sort of two types. You can go point to point. So if you absolutely know that processor 37 needs to send something to processor 2, you can do that. But more often, what you do is some type of collective things where everything is communicating with everything, or you're doing some kind of global reduction, right? Because you want to print something out. In that case, you're gonna suck in information from all the processors to one and print it to the screen, right? Or something like that. So that's more about the MPI4py. And I was actually going to write some code, but I think, let's see. I was messing with it before class, and I think I fouled up my installation. Oh. What did I do with it?